Hello and welcome to today's webinar, One Size Doesn't Fit All, Choosing Your VR Solution. My name is Mandy Joyner and I will be your moderator for today's webinar. Before we get started, just a few housekeeping details. First, everyone will remain muted throughout the webinar. If you have a question, please use the chat feature in the bottom left-hand corner of your screen and we'll answer the questions at the end of the webinar. It is being recorded and will be available for all attendees. At the beginning of the webinar, we will be asking a few questions and we'll ask you to raise your hand. You will see the raise hand also in the bottom left-hand corner of your screen. If you need to adjust any settings, they're here in the top left corner. With that, I'd like to introduce our presenter, Matt Lansky. Matt Lansky is a graduate of the Electronic Visualization Lab at the University of Illinois, Chicago. The cave was invented. Matt started in the lab in 1994. Only 2 years after the cave was created, and as a scientific visualization and VR developer for Argo and Mac9 to become the software division. After many years in technical and product management roles, Matt now serves as account manager, where he uses his engineering background in a teaching style approach with his clients. His focus remains on problem solving for the organization he works with, while maintaining an engineering mindset in his day-to-day interaction. Matt?
Thanks, Mandy. And thanks to everybody out there who's joined this webinar today. Hope everyone finds it interesting and useful. Go ahead and let's next slide here, Mandy. So I'd like to start with a quick question or two, well, maybe three here for everybody involved. I'd like to first just take a quick little survey of those in attendance. Who out there is frequently using a VR system today of any type? And you can click the raise your hand button if you're using one. Just want to do a quick kind of an informal survey here. Okay, you can lower your hand now for this one. We'll go on to the next slide. So of those who are using VR systems, how many folks are using a head-mounted display or a wearable display? So if you're using a in your day-to-day work, a Vive, please go ahead and raise your hand. Okay, so a handful of you. And how about a projection-based system, or like a Cave or a Cave 2 or a Powerwall? Okay, a few of you. Oh, okay, great. Thanks. So go ahead and pop to the next slide here, Mandy. Quick point of order here is that this presentation is not a sales pitch, and it's not even meant to provide a mandate of when a Cave or an HMD is better than the other. Mac9 delivers both Caves and HMDs and everything in between as solutions to our clients, and really believe in finding the right tool for the job. So if you're expecting me to say how Caves are great and that HMDs are awful, you may be disappointed. Instead, I'm going to try to highlight some of the pros and cons and capabilities of each, so that if you are investigating using VR, you're armed with the questions you should be asking yourself, your stakeholders, and your users, so you can come to the right decision for your needs. So having said that, please allow me at least a slide here to mention Mac9 and what we do for those of you who don't know, or those of you who might not be aware of everything else we do. Many people do think of Mac9 as the Cave company, and I would say only about 10–15% of our business is traditional Cave systems, and maybe 30% is VR. Other than that, in addition to that, we provide a variety of integration, software, and services to our clients with a mixture of design, build, and support to provide fit-for-purpose AV and IT solutions to different organizations worldwide. We have obviously done a variety of deliveries in VR, including HMDs and augmented reality. We've also developed software for doing things like remote graphics, a product called TGX, and we also provide on-site technical services. I've given this talk a few times now, but both have been in front of a live audience, not via webinar, and I am more used to public speaking than this format. So if I falter or stumble along the way, please forgive me. Also, please don't hesitate to post questions as you think of them. If I can answer them in line, I will. If not, there's also a Q&A session at the end, and we'll be sure to cover everyone's questions before the end of the webinar. So why are we here today? Well, the motivation of this talk was actually driven by NVIDIA. They asked us to provide a talk at their GPU Technology Conference because there's so much noise and interest and hype in VR today. But it's all been around HMDs and wearable devices. And NVIDIA wanted us to present at the GTC to let people know that that is one type of VR solution, but that there's also many others. We didn't want to make this a sales pitch. We really wanted to focus on helping organizations try to determine the best tool for their needs. And so that was kind of the premise for this talk. So based on today's media and stories out there, you might be thinking this technology of HMDs and wearables was only a few years old, and many people think these are brand new inventions. But head-mounted displays have been with us for a long, long time. And you can see in this slide here that there are quite a variety of display systems that have been used over the years, and even projection-based VR display systems have been around for 20 plus years. And so here's an example of a projection-based system, one of our wave systems, where all the screens are, or all those are screen-based projection. In addition to projection-based systems, there's also panel-based systems, which uses LCD as display technologies. So these are just a couple of examples of the type of VR display systems that have been around for a while, both HMD and projection-based. So why all the fuss now? Well, the big reason is cost to entry. There are many devices that are under $1,000 today, not including the PC workstation. And so with this lower price point, there has been a very renewed interest in VR solutions and technologies. So just a quick background here. So what makes something VR and not just 3D? A lot of us have gone to 3D movies. What's the difference between 3D and what is virtual reality? There's a few generally accepted capabilities that must be available for something to be considered virtual reality. One, obviously, is 3D stereo, and that's the ability of each eye to see a slightly different image of the world at different from different viewpoints. Another one is viewer perspective, or perspective projection and parallax. These capabilities for perspective projection and parallax generally require some type of tracking system, which gives the software the 6th degree of freedom information for your viewpoint, so your position and orientation of your head. Some HMDs may only have rotation capabilities, which does allow for look-around capabilities, but may not provide parallax of objects to help in determining distances. And we'll get into that, both stereo and perspective, in a few more slides. Field of view has also generally been one of the metrics or requirements for VR. Our field of view as humans have a very wide vertical and horizontal field of view, and being able to display that and fill our periphery has always been an important factor in VR displays. So for 3D stereo, in this image here, you can see on the lower right, this is kind of a top-down view of the user's eyes. And the closer an object is to a viewer, the more inward our eyes turn to focus on it. And this is stereo focus. So I'm going to do a little exercise right now. Everybody can try to follow along here. It's a little bit more difficult without video. But I'm going to ask everybody to hold up their index finger on each hand and place one of your hands about 8 to 10 inches from your view, from your eyes, and the other hand completely stretched out. So you have one index finger in front of the other at some distance. And I'm going to ask you to first focus on your near finger, and then now focus on your far finger. Now focus back on your near finger. And that is stereo focus. That is your eyes turning inward to look at an object or focus at a particular distance. And these are one of the visual cues that help us determine distance of objects in scenes. And so the ability for each eye to see a slightly different image based upon the position of the eye relative to the object helps us determine distance and provides that 3D stereo effect. So if we go on to the next slide here, viewer perspective is also a very important characteristic of virtual reality. And in this case, you can imagine the woman sitting at the desk is looking through a picture plane and seeing a box on the table. Well, that picture plane represents the screen or video image of the virtual world. If that was just a piece of glass and she were to move her head to the right, she would no longer see just the front of the cube, but she would see the front of the cube and the side of the cube, just by changing her position relative to the object. In the virtual world, we want the same thing to occur. So if that cube was a virtual object and the person moved their head relative to the object, the view on the screen should change. So regardless if this is a cave or an HMD, by tracking the person's viewpoint, we're able to see the object from a different perspective. So once again, let's do the exercise by holding up your fingers, one close and one far. But this time, close one of your eyes, all right? And now move your head side to side. So the world obviously changes, but also you'll notice that the closer finger moves more relative to the world behind the back finger. This is considered motion parallax, or called motion parallax. And it's also another visual cue that helps us determine distance for objects in the world. And same thing in the virtual world. So by tracking a person's head position and orientation, we can create a perspective view that also allows for parallax. This is why many VR systems require a tracking system to provide that data to the software and be able to generate the correct views. The next one is field of view, or which helps us provide immersion, or feel immersed in the data. Humans have about 200 degrees of field of view vertically and about 150 degrees horizontally. And we can do another little physical exercise here. And this time I'm going to ask everybody to hold up their index finger on each hand, but put your arms out to your sides while staying focused forward, your eyes focused forward. Move your eyes or move your hands slowly to the sides of your head. And you'll notice if your eyes stay focused forward where your fingers cross from in view to out of view. Now, without turning your head, but turning your eyes side to side, you'll notice that your eyes or your fingers can actually be moved a little bit further back, completing the field of view. One of the big advancements in HMDs that allowed them to become so useful in recent years has been the optics. Part of the difficulties with previous HMDs have been their field of view. And when looking through older HMDs, you would see more of like a postage stamp or a miniature view of the world. And now with some of the optics that are in things like the Vive and the Rift, one of the pieces of magic, so to speak, was the ability to increase the field of view through lenses and optics. And that is what has really helped increase the sense of immersion and sense of presence within these VR devices. Some other valuable characteristics of VR include interaction and navigation. This is the ability to move about the world, interact with it, grab objects, just like you would in the real world. Collaboration, or being collaborative, so the ability to interact with other users, whether virtual or real. Having audio for feedback or to add to the experience. Realistic rendering and true scale, being able to see objects and their life size. So these are all things in addition to the stereo, the perspective projection, and wide field of view that are generally considered useful for virtual reality. Okay, so we've described the technology of what makes something VR or virtual. All right, but technology on its own isn't really beneficial. And to use this solution, or to use VR, you're really looking for what's your return on the investment. And so I thought this was an interesting quote that I found online. The technology provides no benefits of its own. It's the application of technology to business opportunities that produces ROI. And whether it's an academic, a government agency, or a commercial entity, we're all businesses in some sense and generally need to provide value for the work that we're doing. So one of these examples could be using virtual reality in design decisions in manufacturing. Here, VR could be used in reviewing early mock-ups or designs, sub-assemblies, and parts. It may involve teammates from other groups or departments within the company, such as manufacturing or service divisions. And by using this technology, they may see or uncover issues that could cause problems further downstream in either the assembly, manufacturing, or maintenance of a product. And if these products or potential problems could be found earlier, like during the design phase of the product's life cycle, it can save costly change orders, redesigns, and retooling later. This is a very common example of how VR has been used in manufacturing. So cross-functional team collaboration has been another one. Imagine you needed to explain the inner workings of how an automobile engine works, or how a cancerous growth was interfering with normal body functions. When we attempt to teach or communicate new ideas to others, it really helps if we can show them visual subject matter, as well as interact with them through verbal and nonverbal cues, such as pointing or other gestures. I bring this up now as one of the points you'll want to consider when determining the best VR solutions for your needs or use cases. When you go to investigate these systems, one of the things you need to ask is, will it be useful or even necessary to be able to interact with others physically and not only virtually? And so kind of keep that question in the back of your mind. Another way VR has been valuable is to look at equipment or information in life size, aka one-to-one scale. We can make better decisions and collect more information when we see things, something true to size, especially when it comes to areas like architecture, ergonomics, equipment assembly. It's one of the reasons why when you go to a new neighborhood development, the builders often build model homes first. Prospective buyers don't feel comfortable trying to buy a home that they've only seen as 2D blueprints or as a scaled-down model. There's something about seeing content in life size that really helps us get the best feel and understanding of what we're looking at, we're trying to study. Even companies and organizations that employ very skilled engineers, that are used to viewing and reviewing designs on the desktops will still very often build physical prototypes at life size, one-to-one scale before we're going to manufacturing. Using VR helps in that way. It doesn't necessarily remove the physical prototype's complexity, but it often lessens the iterations during the design phase and allows organizations to come to a final design quicker and get their product to market faster. Another way VR has been used has been in a hybrid environment collaboration. And in this type of system, it's a large format display that allows collaborators to interact with multivariate data, both 2D and 3D, as well as verbally share their findings with the rest of the team. And so this is an example of two scientists looking at same data simultaneously, but in different formats. On the right, they're looking at 3D data of subsurface data underneath the Antarctic, and on the left, they were looking at either I can't remember if they were acoustic, like a sonogram type data, but the two scientists were both used to looking at data differently, and they were using this to map some subsurface regions under the Antarctic. And so another thing to consider is the types of data that you'll be viewing or looking at when considering the VR solution that's best to your needs. And then another example here is in virtual collaboration. You have tasks that require multiple people collaborating together. Examples of that could be complex surgeries, mounting ordnance to a bomber, doing large assembly equipment or repair. And in these types of use cases, we've even seen needs or use cases from our clients where they couple a spatially or projection-based display with multiple HMDs and allow folks in the spatially immersive display to kind of have an omnipresent or an outside view of the users who are doing the collaborative work together. So one of the things to consider, or a little chart I put here together, is kind of comparing HMDs and caves and some of the capabilities that you might need to consider when looking at different VR solutions. So one, of course, is resolution. And with resolution, that affects the fidelity of the data that you can view. Another one is self-awareness, the ability to see yourself in the environment. With HMDs, that's often closed off if it's not a video pass-through HMD. In the cave or other projecting displays, you can often see yourself or others. Similar to that is the awareness of others. With an HMD, they're a little bit isolating. In a cave, there's obviously virtual and real participants are visible. Sense of immersion. The great thing about the HMDs is you can look 360 degrees in every possible direction and expect to see or be immersed within the virtual data or the virtual world. With caves or projection displays, that's not the case. There's almost always, at minimum, an entranceway or an area that's not covered by a display, and so you are somewhat limited in your sense of immersion. User areas, with HMDs, you got to be concerned about being tethered right now until they come up with newer wireless ones. Within caves, it's variable, depends upon the size of the area. Collaboration, the ability to interact with others. Right now, in most HMDs, it's virtual only. You need a virtual avatar. You need a remote participant to be connected through the software. Within caves, collaboration is easy and common, whether it's done virtually, like the HMDs, or done physically with your teammates and other members of your organization standing side by side. Comfort level is another one. HMDs tend to have a shorter eye focus and cables. Some of them have a greater chance of simulation sickness because you don't see yourself or the real world around you. But some things like the Vive, I've sat in the Vive for long periods of time, and it was very comfortable because the tracking latency was so good. Probably some of the best tracking latency I've seen. Whereas the cave system, even if there is some latency or lag, depending upon the tracking system, the sense of self-awareness has generally provided a little bit less motion sickness or simulation sickness. And there's also lower risks as obviously trip or fall hazards because you can see the physical world around you. And then, the next item on here is cost. Obviously, HMDs are a very low cost price point compared to high-end projection display systems or panel display systems. And these are just some of the capabilities when trying to compare these types of tools. And I really only listed the HMDs and caves here, but you could probably come up with similar ones for power walls, benches, and other types of VR systems. So that's kind of set the stage. That's been the overview of VR technology and use cases. And I did that to, like I said, kind of set the stage and now go into kind of the next section of the talk on, okay, what can we expect and where do we go from here? So the first slide here, the next slide here in this section, is one of the Gartner hype cycle. And the Gartner hype cycle has been a published, set of stages that many technologies go through. And those of you or us who have been involved in VR for a long period of time have realized that there was a kind of a bleak period there where VR, especially projection-based and panel-based VR, kind of sat in that trough of disillusionment. It came out with a lot of hype in the early mid-90s, late 90s, I think it was overpromised as far as what it was going to be capable of. I think it fell into this trough of disillusionment with a lot of organizations. But then slowly over time, technologies increased, capabilities got better, adoption increased. And I would say that the large-scale or immersive VR systems are kind of sitting somewhere in that climbing the slope to entering the plateau phase. Not quite sure exactly where it sits. But we obviously have had multi-generations of systems. They're being adopted. It is not what I would consider very wide adoption, but it is adopted through a lot of organizations at a lot of different levels. An interesting question, and I don't claim to have the answer here, and people can feel free to chime in if they want on where they think it sits, but it's interesting to think where these new HMDs are sitting and headed. One possibility is they're on the coattails of their predecessors in other VR, and they're going to go right into the climbing the slope and entering the plateau. But now if the content and the development doesn't happen, there is a risk that these new HMDs and solutions are going to hit that trough of disillusionment. I'm not really sure what's going to happen, and I'm not going to place my bets, so to speak, but it's going to be interesting to see over the next few months and years where these new HMDs go. I really do hope they are already in the climbing the slope, because I think there's a lot of good things that would happen if it is, and that would include the next slide here: growth, and more growth. With these solutions, if the content is there, if the source is there, I think adoption and acceptance by mass users and consumers is going to happen. I think it's just going to increase the availability of VR-capable applications across the board. Things that aren't just only HMD capable, but can be applied into other VR solutions. I also think new collaborative and remote communication paradigms are going to happen. So I think this is a really interesting and a great place for VR in general, and I know I'm pretty excited about what's happening. So with this lower cost, what's going to happen is obviously greater accessibility. There's going to be more adoption by Tier 2 through Tier 5 suppliers in the supply chain, folks who might not traditionally be able to afford higher-end VR solutions or systems, or maybe I say more costly VR systems. There's going to be access by students in high schools and primary schools. Most VR systems that we've put into academics have been universities. Places of higher education. And I think with the prevalence of lower costing systems, it's just going to drive down into earlier adoption in our education system. So what else can happen is more ways to engage and visualize and interact with content. There's going to be new companies popping up all the time to develop new content for these systems. And again, I think across the spectrum of VR solutions, we'll all be able to take advantage of that, whether it is an HMD, a cave, a Powerwall, a Cave 2. I think these are going to continue to proliferate and really drive up the availability of content and new applications. So what else might happen? Well, hopefully we start eliminating some of the constraints of 2D discussions and presentations. Maybe this generates a new form of communication and social media. Social media has always been a driving force of communication and technology, and I see no reason why VR and head-mounted displays won't be part of that as things move forward. And just like the gaming industry driving some of the graphics for us, for those of us who or you or us who have been around in this industry for many years, when we were able to move away from the big iron and the specialized compute, and we were able to go to the PCs and workstations, it really opened up a new door of capabilities and price point on being able to have a VR system. And a lot of that was driven from the gaming and entertainment market space. The ability of the NVIDIA graphics cards and GPUs got so good because of the entertainment space, and many of us who, like I said, have been in this for a while, took advantage of that and allowed us to start driving these larger, multi-projector, multi-panel display systems with clusters of commodity PCs. I'm hoping there's a similar effect going to happen with this, with the new HMDs driving, like I said, a trickle effect and bringing new capabilities that can be applied to all users of VR. Okay, so if you are in IT or engineering, what are some of the things you might be required to do? Well, you might now be in charge of acquiring or supporting a VR system for your organization. You might be tasked to use VR as part of your workflow. You might need to become an architect to develop a solution in VR for your users and clients. But unlike the architect in the picture on the right on this one, I hope everyone's a good architect. So how are you going to accomplish this? So recall the title of this meeting was One Size Doesn't Fit All, the importance of aligning VR environments to your workflows or choosing the right VR solution for your workflow. When I'm working with a client that's new to VR, many times they come to me with a preconceived notion of what they want. They may have only ever seen one type of display, whether it's a cave or an HMD or something else, or maybe only their boss did, and this person has been assigned the project to investigate it. So when working with someone new, and even people who are experienced, I always kind of like to start with this exercise. I want to ask them to forget about the technology and instead, in just plain English and plain simple words, describe what they want to be able to do. I say, imagine it's the first day that your new VR lab has been installed. You walk into the lab, you turn on the light switch, and you press the start button or the easy button. What happens? And I kind of leave them with that and let them take some time, whether it's an email or a phone call, and get back to me with what they want to have happen. I always try to start with this exercise because it helps users define their use cases. It helps them determine what problems they need to solve. You know, how does it look? How does it affect their senses? What decisions does it allow them to make? And so when you're considering using a VR system or a VR solution, I would encourage anyone on this call or this webinar to do the same thing. Put the technology aside for a second and ask yourselves what you want to accomplish or what you want it to do. When doing that, here are some other things to consider. These are some of the questions you might ask yourself. Are you going to have simultaneous users? How large of a range of motion is necessary? Will being tethered be an issue? Okay, so will any of these items affect your ability to interact with your data, your content, your collaborators? In the picture on the right, you can see that there's an auditorium filled with a few hundred people that didn't notice Mark Zuckerberg walk into a room. It's a pretty compelling image showing the problem of isolation in many of today's HMDs. And I don't say that to try to knock down the HMD. I think HMDs are very, very useful and are going to proliferate. And obviously, there's solutions that we provide. But there is currently an isolation effect within many HMDs, and that's one thing you want to consider when looking at VR solutions for your organization is how important is the face-to-face collaboration? How important is virtual collaboration? And remember to ask yourselves the types of questions that are going to help you pick the right solution for your problem. So some other items to consider is, will the occlusion or inclusion of the physical surroundings help or hurt your experience? Okay, so in some cases, occluding the physical world and being completely immersed in the data and complete 360 degree is going to help you solve your problem better. In some instances, being able to see your physical self or physical others may help you with that. So there's a spectrum here between a real environment and a purely virtual environment. And some of the terms that have been thrown out here have been augmented reality and augmented virtuality. The real environment, I think we're all pretty aware of. It's what we're seeing without any type of wearable or compute. An augmented reality environment is similar to like a Google Glass or a HoloLens from Microsoft, where you're applying some graphics or data on top of the real world. You're augmenting your reality. Augmented virtuality is more of seeing virtual objects, products, content within the 3D, also within the physical world. And where augmented reality might be calendars, phone books, TVs, augmented virtuality is a little bit more immersive, greater sense of presence, and more of a virtual environment. And then all the way to the right, the virtual environment would be the completely immersed, non-physical, all virtual display. In addition to that, there's still even some more items to consider. And some things you may want to think about is, does the system require any specialized compute? Because there's always a complexity with compute and clusters. What's the resolution of your data, the fidelity you need to see it? And if you look at that center picture there on the bottom, application called Connectome, and it shows pathways or connections in the human brain. Each one of those panels is an HD display. The only way these scientists could see this data was in a very high resolution display system. If they were to try to look at all of that data on a single HD display, they wouldn't be able to have the visual acuity or the fidelity to see all of the individual connections. Many of those lines would be at the subpixel level, and it would become more of a blur of colors than being able to see it. So take into consideration not just the interactions you want to be doing, whether it's collaborative or isolated, but you need to consider the data you want to look at and what's the right fidelity for your type of data. Scientific viz very often uses more high-res data. Same thing with unmanned aircraft or satellite imagery. CAD applications, especially CAD data that's false colored and maybe not photorealistic, generally can work with lower resolution data, has been our experience, or my experience. So take into account the type of questions or fidelity you need to see. And then the availability of applications for your area of interest. Is it going to be easy to develop for that platform? With the Vive, there's been a lot done with VR Steam from Valve. There's a variety of applications for caves and other VR systems and power walls. But take into account the type of content and data that you want to look at in addition to the physical characteristics of the technology you're looking at. So I'm hoping that this has provided everyone with some ideas or things to consider or ask themselves when considering a VR system. I tried not to promote one technology too much. Obviously, I mentioned caves a lot because caves are something to do and HMDs, but obviously there's a wide range of VR systems that are out there. And so I really want to turn it over to the audience now and see if there's any questions that people want to ask. So we'll take a look at the chat session here and see if there's anybody asking anything. So one thing that I've heard in my other talks, well, I'll wait to see if anything comes in. Question that came up in my other talks that I've done is, is there ever a need for both wearable and projection-based displays? And I actually added a slide a few slides back of an example of several users walking around HMDs. And we've been finding more and more clients interested in this type of setup. We've been finding that if an organization's already been planning or interested in a large-scale display, it's a pretty small addition to also add an HMD technology. And it gives them kind of then the best of both worlds, where you have the HMD user who can be fully immersed, but then you can also have a group of collaborators seeing the same content or seeing the same view as the HMD user, and either watching them work, watching them perform the task, or providing feedback to the HMD user. And so we are seeing that many organizations are looking at a mixture of both types of systems. So Mandy's shaking her head no, that there hasn't been any questions pop up in the chat board here. Oh, wait, something just came in.
So this says, great intro to AR and VR. Do you have any recommendations for streamlining the creation of 3D content, either from scratch or from existing 3D stuff?
Okay, so streamlining the creation of 3D content. That is a good question and a little bit of a difficult one to answer. There's generally always a bit of person in the loop work to get 3D content into VR. It does depend upon the technology and the approach that you use. I'm going to answer this one a little bit on behalf of Mechdyne's products because that's what I'm aware of. So one solution that we have or use is something called Conduit. And Conduit is a mechanism to display desktop applications and their content directly into VR without any data preparation. Now, it works by intercepting the graphics at the desktop and then re-rendering them in a VR system. So a user doesn't have to do any data preparation. And we support all of the main CAD programs like V5 and ProEngineer and Creo, the Siemens products like NX and Teamcenter, Process Simulate, but we also support things like Google Earth and Google SketchUp. Now, that really is a view of the desktop application in VR and doesn't make it an interactive VR application. If you're looking to make a more interactive VR application where you can pick and grab and move and choose things, there are products that are out there. There's also toolkits that you can build from. One is Unity, and we have a plugin that allows Unity to run in different VR systems. If you're focused on something like the Vive, Steam VR has been very successful on the Vive HMD. And that is something that we're actually looking at and considering to see if there's a way to use that across multiple VR systems. And maybe there is already, and I don't know the answer to that, but okay, so.
Another question has come in. Any attempts to standardize on platforms so they're cross-compatible? Content is often the problem.
So that is another very good area, and it's not an area that I would say Mechdyne is directly taking head on. We too are somewhat dependent upon the industry and other gaming companies and content creators and looking at what's going to happen. From a recent article that I read, I do believe Steam VR or Valve, who makes Steam VR, is really trying to promote their platform as one of the ecosystems to be cross-compatible. And so, again, I think there's a lot of competing solutions right now that includes Steam VR, it includes Unity, it includes Unreal. Everybody's kind of competing for the space, and I can't predict or say what is going to become standardized, if anything, but there are at least a lot of solutions out there right now. Now, if I don't answer any of the questions as intended, please feel free to ask again. Okay, so next question.
Another question has come in. We want to develop a VR degree program for content creation and also teach classes through VR. What would be the best platform to use as an instructional tool to do this at a community college?
Well, that is another great question, and I think there are a lot of options that you can consider. I think that one I would love to take, well, I'll answer it, but then also would love to have someone follow up with you, John, offline and discuss your specific use cases and needs, because that's a great question, but I think we would want to know a lot more information about your college, skill sets, what you're trying to accomplish to make the best recommendation. But certainly, like I said, products like the HTC Vive, the Oculus Rift, gaming engines like Unity and Unreal are both really good, as well as, I believe, Steam VR. And we've seen universities adopt products like that or tools like that because they're fairly easy to develop, work with. They can be used at the desktop. We've seen universities use things like Unity for gaming classes, but then also applied into VR. So hopefully that gives you kind of a touch of an answer, but I think a more in-depth discussion offline would be helpful, and we would love to have that with you. I think Mandy's maybe scribbling a note to try to contact you. Okay, so next one.
Let's say you have an OEM with a 3D model being viewed on their cave. Several remote suppliers need to participate. Can the 3D model on the cave be fed to HMDs as the suppliers for their participation?
Short answer, yes. And it will depend upon the application or software that's in use. But there are ways to do this. We've done this with our Conduit software. Our Conduit has remote collaboration capabilities. We've done this with Unity. And so the short answer is yes, there are ways to do this. And I would also default saying, William, that, again, I think a more in-depth conversation on exactly the formats and types of data that you want to view, the connectivity that's available between the sites, the types of displays, all of those are questions we would want to get answered to kind of help direct you towards the best solution. But again, short answer, yes, this is absolutely possible. People are doing it today, and there's more than one way to do it. We would want to work with you to figure out what the best way is for your needs.
Okay. Next question that we had come in. What kind of support for WebVR is Mechdyne anticipating, or do you have any thoughts in general on the viability for WebVR?
Unfortunately, I don't have a lot of information on WebVR. I think that might be a telling answer in that we don't get asked about it very often. So I haven't seen much about WebVR, haven't heard much about WebVR, haven't been asked much about WebVR. That doesn't mean there isn't value with WebVR. I just want to be honest and say that I don't know to be able to answer that question. But in many of my conversations with the organizations that I work with, which are mainly in manufacturing, WebVR has not been brought up to me very often. So sorry, I don't have a better answer on that other than just to say it hasn't been high on our radar at the moment.
Okay. Next question, does TGX support VR sharing?
So TGX does have, I'm trying to remember if it has had or is in the process of doing 3D support. But as far as VR sharing, I don't think TGX is necessarily the right tool for VR sharing. The reason being is that TGX is really made as a screen, more or less a desktop or a screen grab of sharing. Now, that could be 3D content, but with VR, especially in collaborative VR, you would like each participant to have their own viewpoint. And so you really want, if you have remote collaborators, both in VR systems, you want them to have the same data, the same content, but you want them to see it from their own perspective or viewpoint. We just got a message in from a teammate that says, I guess VR support in TGX is in process. I don't know to what level, but that is something we could also follow up with you and provide those details offline. Okay, next question.
Okay, this next one is a little bit of a scenario, so stick with us on this one.
All right.
Using Process Simulate with a digital mannequin, Jack, eventually coupled with mocap gloves, wanting to manipulate small components in real time, fine motor skills like fingertip motion, and show on a larger display. So let's think of the mannequin operating wearing an HMD while visitors are viewing activity on a large display. Is this feasible?
I believe so, yes. And we may have done something similar to this for one of our clients where we used Conduit to render Jack in multiple VR systems at the same time. So if you have the glove interaction working with Jack, let's just say at the desktop or at some level, and that you have that part available, and you just need to now render it and see it both in an HMD and a larger display simultaneously, yes, we can do that. And we do that with our Conduit software for Process Simulate. So love to follow up with you on that one and share our use cases and examples with that and talk to you more. And so we'll make a note to follow up with you on that one, Duncan. But yes, that should be feasible. This is great. Lots of questions. Happy to talk for a few more minutes. If anybody else has anything else that they want to ask, please chime in or type it into the chat session there, and we'll get to it. So give another minute or so for people to type in case they're typing, and if not, we'll end the session here. I'm hoping everybody has found it valuable or interesting. If anybody doesn't know how to contact us or needs us to contact you, please just make a note in the chat session to say, please contact me, and we'll be happy to do that. How about 64-bit GIS data? And a typo, maybe? I'm sorry, I don't understand that question, Javier. Can you please repeat? Well, thanks for attending, Duncan. Appreciate it. 2 more seconds. All right. Well, if nobody has any other questions, thank you very much for attending. Please reach out to us. And oh, Javier's asking something. Oh, thanks. Oh, well, thank you, everybody, for the kind words.
Just as a reminder, the presentation was recorded. It will be sent out to all attendees who registered and attended, so that will be coming to you in the follow-up, along with any contact information. So if you do have follow-up questions, we're happy to reach back out to you, and you can ask as well.
So Javier, yes, GIS data is visible through a variety of ways. One, again, MECDON has a product called Conduit, and we have support for ArcGIS from Esri, as well as Google Earth. And so there's certainly ways to view GIS data. Yep, and simulations as well. So happy to reach out to you directly and hear your needs on that one, Javier, and answer any questions you may have. So thanks again. I really appreciate everyone attending this. Again, this was a new format for me in the webinar. I hope I did okay. And good luck, and everyone have a wonderful rest of your week. Thank you very much.